Welcome, everybody. This is Priyanka Jain from A-Ring, and you're listening to the Analytics Cafe podcast, the show that sheds light on practical analytics and data science topics for people in business who love to put data to work. Today, we are talking about model deployment governance with Juan Gorricho, a seasoned and senior executive from Fortune 100 FinTech with significant pedigree in running large scale technology operations. Welcome, Juan. Would you please introduce yourself?
Thank you so much. I've been doing data work for the last, I don't know, 20 years, right? I've been in multiple organizations. The last, before my current role, I was with a payments processor, and before that, I spent about 10 years at Disney. But my passion has always been sort of in this intersection of technology, data, and business, right? And how do you actually create practical, very pragmatic solutions that deliver value to business, right? So that's my undergrad is in industrial engineering, and I have an MBA from University of Virginia. So I'm not a technologist, but again, that point of intersection between using data to solve problems through technology, that's where my passion lies.
That's great. That's great. So going back to my question, why are we talking about model management governance?
Yeah, I think it's always interesting because people are, as you were saying, very interested in talking about the nice, sexy stuff of model building, which is all the AI and the ML and the TensorFlow and the things like that. But sometimes people don't realize that there's also another side of doing modeling the right way, which is, how do you make sure that your models, are unbiased, right? That they have the right data and data quality and controls in place, and furthermore, that it's being monitored and managed because, models and data change over time, which will impact the outcomes of these models, right? And I think sometimes it has to be a balance between those two things, the sexiness of the model and the innovation on how you build models with more advanced solutions. But on the other hand, a critical component is, you know how are you making sure that the model is supposed to be doing the right what it's supposed to be doing? How do you make sure that the data that goes into the model follows the right patterns and the right quality? And how do you make sure that as the conditions of the environment change, that you're monitoring the model to make sure that it's doing what it's supposed to be doing, right? So it's a little bit of a parallel to, in the data warehousing world, in the BI world, people always talk about, the dashboard and the KPIs, but very few people talk about the data quality, right? And the underlying foundation that is needed to do. Similarly, I think in model development, you have the same concept. Models need to be monitored. How they were built needs to make sure that is understandable, and you need to make sure that you understand how they are behaving, so that as conditions change, you know how to react and change the model. Does that make sense?
Yeah. So I think what in the gist, what you're saying is that, and you talked about many things here. You talked about model deployment. You talked about governance there.
Yes.
You talked about the ability to do monitoring so that when the model is deteriorating, that you are, you catch it at a good enough stage. So there's a lots of components in here. It's just not about was I able, like 0 1, was I able to productionize my model to get my latency. Now let's just take a few steps back. Broadly speaking, for people who are starting on their journey of data science, broadly speaking, I'll just lay it in simple terms. When we are talking about model, we're talking about statistical model or machine learning model or AI deep learning model, where you have some complex ways of describing a y an outcome based on some input variables. So that's a model. And so the outcome of model can be twofold. One outcome, one very common outcome of model is it's insights, right? You build a churn model and you found these are the 3 top reasons for your customers to be churning. Typically, that's not a model you'll deploy. That's a model that you'll use for insights. There's another set of models that you'll build. For example, we were just talking about we're talking about recommender system, and some of those other product kind of model. That will be a model that you'll deploy. And when it comes time to deployment, there's a whole infrastructure needed end to end. Model building is another aspect of it that I think many people talk about it. But today our focus is talk about what happens after you've built a model. How does that get into your decisioning system, whether it's on your website and somebody's filling an application and you're saying your application reject or accept, or if it's somebody on a call center taking your recommender system and appropriately reading out some options for your customer, or whether it's something where people are shopping and they have added something in the cart and you're giving them 2 other options to add, right? It can be any of the forms. But how does it get from I have a model y equal to something, some equation is there, to now my systems, my people, my processes are using this model? And that's the space we are talking about. And what I understood, Juan, from you is that there are many aspects of it. There is there's the governance, there's the maintenance, there's the monitoring, there's the who needs to be using it and how they need to be using it, and when it basically deteriorates, how do you catch it? So we are talking about that. So what's the challenge? What are the challenges in that process?
Well, I think that there's several, right? I think, and I will say that while I'm not a deep expert on this space, and my introduction to this topic was a few years ago when I was the chief data officer for Disney's credit union, in which we were building a new set of decisioning models for credit risk management, like to basically, approve or deny credit for credit union members. And so as we started working through the model with the company that was developing the model, they actually brought a lot of experience that they had with the federal regulation that exists in terms of, model governance, which is like very well developed, that is precisely put in place to make sure that these types of models that are high risk models because of the outcome of the decision can be impactful to an individual are unbiased, right? Like,
Yeah, you
if you
can't
build a
use
model,
gender.
exactly,
You can't use race.
or certain type of attributes that like, zip or things that actually will lend the model to be biased, right? So precisely this was put in place in the financial services industry as a way of making sure that these models were doing the right thing, right? And so my position is that while that space in financial services is very well regulated and there's a ton of experience, I mean, there's banks and issuers that have full-blown departments that actually their only job in life is to do this. If you abstract from that, at the end of the day, all this is suggesting is that you should have a set of good practices to make sure that the unintended consequences of a model are identified, right? And I think, it all goes back to the risk, right? Like, if you have a spectrum of risk of a model making, decisions that have low risk or low impact on your business, then you probably need to be less rigorous in making sure the model isn't biased. But if you have high risk decisions in which you can be impacting, both reputationally or financially risk, some of those dimensions, then you have to be much more rigorous in making sure that the model isn't doing those things. So, to me, again, even if in my prior role, for example, before I joined my current organization, we were technically not required by regulation to do any of this, right? But again, because our clients, many were in financial services, right? And the moment you start talking to those clients to say, we have built a model to solve this problem, it triggers sort of the notion of like, oh, model means model governance, show me your model governance documentation. So we actually started proactively producing it to make sure like, hey, this is first of all how the model is built, right? So this is the algorithm, right, that makes sure that how it produces. Second of all, here's how we built it, and here's the data quality controls we put in place to make sure that the data was meeting the controls that the requirements the model needs. And third of all, this is how we actually monitor to make sure that the model doesn't change, right? So again, if I summarize what I just said, is like it's a little bit of just best practices, so making sure that the models are built the right way. And you will do more or less of that depending on the risk or impact of your model. But in general, it's just good way of doing things to make sure that you are delivering the right outcomes in the right way.
Yeah. So Juan, I think you were touching on some of the processes aspect of it. Like, do you have your dictionaries? Do you know the processes of, the the variables that you used for your, as your predictors and all of that. What about the tech stack? What about the operationalization of, here you're building the model. Most of the time, most of us data scientists, we are building stuff in Python and R these days. And that can be sitting in AWS tech stack or any other tech stack. So how do you, there's whole aspect of model building. All you need to do is fire up your Python and download libraries or R and download libraries and sort of build a model. But that's ad hoc. That's one time you pulled your data from your S3 and then you built your model in SageMaker and you pushed. But the whole aspect of I have a model now from there to like really it connecting to, let's say I'm building a recommender system now, it needs to connect to your front end production website, which has a database at the end of it, or has some whatever infrastructure you have at the end of it. How does that like the tech stack, how does that work? Because you talked about some of the processes which is in documents, but what about that, the tech stack?
I think that's a great question. I think that the tech stack requirements will vary depending on what are you doing with the model? To your point early on, as we started talking about, you said, well, some models are just being done to produce insights, right? So from a text perspective, you could run those models on a desktop, right? Or in
Yeah,
a
yeah,
AWS instance that you spin off to run for well, and then you shut it down, right? I think
yeah,
that's,
yeah,
and so that's perfectly fine, right? So anything will do from a text
yeah,
perspective, anything
yeah,
that meets the need, right?
yeah,
I think when you go to the other side of that spectrum, you say, well, I now have a model that I want to actually run as part of a business process on an ongoing basis, because the
yeah,
latency requirements of that model require me to rerun that model on an ongoing basis, right?
yeah,
Because the inputs change so much. Then you need to get on the other side, right? So you need to make sure that as data comes, then you have the right stack that actually can respond to the needs of the model. So in the case, for example, of the credit risk model that I was alluding to before, we actually had to implement that model in a tech stack that would scale, up or down depending on client demands, right? Like if the number of credit applications would grow given a promotion, for example, or
mhm,
given some kind of, like new business campaign to increase the loans or to refinance, right? Then you actually had to make sure that the model was, responding in the right to the right latency requirements, because again, as you as a consumer wouldn't be sitting there just waiting for the model to just churn to get an approval or not.
yeah,
You just proceed to experience. So this is, I think, the key of this is that when models are being deployed, it's always good to look at it from a business process perspective, like, and an end-to-end business process perspective. I think the story that you and I were talking before about the recommendation engine is a very interesting one, because what we did, that was in a couple of roles ago, we actually worked with chief customer officer to say, we actually can do better from a recommendation perspective in terms of making sure that clients get better recommendations that are more in tune with what they need. Before we did that, basically call center agents were recommending based on what they knew about the client on the screen, but there was no science to it. So we spent about, we spent about 8 weeks configuring a pilot in which I would say less than a week was spent on the model, because we knew that the bar was low, meaning our maturity in using recommendation engines in that context was very low. So we said,
like a simple
we don't
decision tree would even help.
exactly, we don't need a very sophisticated model. There's something that can just few inputs configure it, right? The most important thing is, like, once the output is generated, right, and once the client calls to the call center, how is the call center system going to pull the data and then display it? How are the agents going to react to make sure that are they actually following the script and recommending? How are they going to document what the client did? And how do we validate that with the data behind the scenes, right? So building that piece, which was a little bit of people in terms of training the people in call center
Yeah,
agents, right? Took us 7 weeks, right? Technology in connecting the data from the model that was the output to the database, then connected to the screen, changing the UI to make sure that it was doing the right thing, and then sort of the process of, again,
yeah,
following these things and capturing it and running this pilot for 3 months. That took basically, that design and implementation of that process took, as I said, 8 weeks. It was like 1 week of model building, right, and 8 weeks of configuring the stack and the right thing. Now, granted, because it was a very simple model. We actually were running it on a batch mode. So we were just taking inputs, running it, and having a predefined list of recommendations for the top clients that were calling to the call center, because we don't need anything more sophisticated.
yeah,
But as the complexity of the recommendations change, like, as we mature in this process, right, and then we say, okay, we can do actually much more granular recommendations, because we are recommending 10 SKUs, but if we have like now 100 SKUs, then we can
yeah,
actually have to much more complex. Or what if we actually make it based on promotions and time? So all these things will require that then your stack grows. And I think the key here is flexibility, right? Because a lot of these processes are
yeah,
going to be, you have, peaks or lows or valleys of demand. So that tech stack needs to be very respondent to those needs. And at the same time, as we talked before, they also have, there's a number of requirements that you need, right? Scalability to meet the latency of the business process is key, right?
mhm,
Um, I think that also it needs the ability to be instrumented the right way, to gather the right data about
yeah,
the model in terms of latency, in terms of outputs, in terms of inputs, in terms of data quality of the inputs, right? And all the things. And then, finally, it has to be kind of, open to be integrated with any other kind of platform, right? Because in this
yeah,
case, we had a call center platform that was, whatever brand X, right? But you had to pull this data via an API. So can the platform talk to it without doing any kind of hardcore integrations? Because the recommendation engine was supporting the call center, but we also wanted the recommendation engine to support, with the same model, support the website and support the app, right? So to be consistent across channels, right? So that sort of, it puts a requirement on the tech stack that you use to make sure that it's open, integrated, and responds with the right latency.
Yeah, and a good point, Juan. When I was thinking about when I was initially asked the question, I was completely just thinking about tech stack. But when you talked about, hey, the agents actually have to think differently and act differently because now they
Right.
have a recommender system. So there's that whole agent, the people aspect that like you usually think about MLAI, and you're thinking, oh, it's just the model needs to give us, yes or no or some answer, and the systems need to integrate. But sometimes the output is that needs to be integrated by people, and they need to be trained by, saying, oh, now I need to talk to a different script, that I need to talk to
Right.
my customer and say, hey, so that's a very good point. And this is reminding me of a next best product recommendation system, an engine I built decade ago, more than a decade ago for PayPal, where we were using, it was a very interesting model again to figure out, how do you, for merchants who were calling in with some problems, this is not working, this flow is not working. After resolving that, recommending a next best product for them, which is, like, oh, you are doing this, you're taking orders on phone as well as website. Why don't you integrate into this, this new product, which is better for you instead of these 2-3 products you're using, and things like that. So, that's just reminding me that the whole
Yeah.
agent, training the agent was a more bigger part. It seemed like more invincible or a bigger task
Well,
than.
yeah, I think to me, like, when it goes back, it's a cliche, right? But it goes back to the people, process, and technology, right? I
Yeah.
think, and even like Gartner now has something that is basically this triangle, has people, process, and technology, and data in the middle, right? Like,
Yeah.
I think it goes to those 4 dimensions, right? So
Yeah.
data is the classic, like, everybody thinks that model building is about just building the model, but you spend 80% of the time just cleaning the data,
Cleaning the
right?
data. That's right.
Actually, and I have actually a nice story about that, of something we did a few years ago. Um, eh, Technology is the easy part, I think. I think honestly, because the tech stacks that you have available today, both on the cloud and maybe sometimes on-prem, are more than enough. Like, again,
Yeah.
it all depends on the maturity we're trying to do, right? And
Yeah.
and the latency you need. Process, we talked about a few minutes ago about that. It's all the, how, can you document how you did? Like, is it understandable, right? If you're in financial services, this is going to be a requirement, most
Yeah.
likely, right? But if you're in non-financial services, this is just good practice, right? That you should do. And then finally is people, right? Which is honestly the most difficult part. Like, of this process of implementing the recommendation engine,
Yeah.
the toughest part was retraining the call center agents to say,
Yeah.
like,
Yeah.
so, like, what do you mean I need to recommend from this list? I actually know my client. I know that if Bianca is calling, I know that she, like, trust me, like, you have to follow this. So we ended up actually, and it's change management, right? It's change management of
Yeah.
people, which
Yeah.
is the hardest one, right?
Yeah.
So we ended up doing actually, competitions, and scoreboards and things like that, which finally broke through. But we had to restart the pilot a few times because, like, honestly, the people wouldn't follow it, right?
Yeah.
Which is again, it's a
Yeah.
challenge.
There's also another part of it, which is, one is, for example, most of the standard statistical model, when you think about your decision trees and your standard regression models, it's like a one-time done and you're done. And then you just monitor the output. The other aspect of it, as you get more mature, is the models which are actually retraining on an ongoing basis. You keep giving the machine learning models, you keep giving
Right.
the output of their decision, especially if it's an output which can be labeled back to the model so that they can
Right.
keep training. So in terms of credit, for example, credit is a case, there is no labeling. Your decision is made, you said no, there's no way to cross check it. So you can't feed that data back to your model. But there are models which you'll build where, you will prove out whether that worked or not. For example, we're working with a client where we are trying to estimate the amount of cash we need to put in the ATM. That cash does run out. So if you can feed that data that, hey,
Yep.
you recommended 5 days it'll take for us to go through cash. Actually, it took 4 days. So you model, you're wrong. If you put that information, label data back into the thing, it's an ever learning process. Now, the infrastructure you need to support a machine learning model truly, which is training constantly, is different than the one where you
Correct.
are pushing the data. Example again, let's talk about AWS stack. You build the model in SageMaker, you push the results back into S3 bucket somewhere. The your production website is pulling that score from your S3 and hopefully with a good latency able to give results in 3 seconds. Well, that's great. Now, if it's a model which needs to be trained on production, on data coming out of production, then you need to feed that data back into the model, and then it needs to keep
Agree.
training, needs to keep putting the output. So that needs to go on while you're doing monitoring of the model itself, which means there are more processes, there are more
Yes.
technological sort of data going back and forth, and more need of automation and so on. So in the spectrum of, here's a static model, I built it once, I'm monitoring it, to all the way to machine learning or even deep learning models, which is continuously learning, like classic are okay Google and Alexa, they're constantly learning. So
Right.
there are two different kinds of model here. I mean, not two, I mean, there are many different kinds of model, and the spectrum in between, and the kind of infrastructure you would need for that will be different. And again, going back to your point of
Agreed.
scalability and governance, who needs to be able to do what? Alerts come in. What do you need to do with these alerts? And at
Exactly.
what point you intercede and say, this model is no more working. Stop the model. What's the plan B? What's the, so there's a lot of components here. So it gets complex and complex as the maturity improves. That, I think, the
Yep.
gist of all of this, my big old rant, was that it doesn't. Go ahead, Juan.
No. So sorry, I didn't mean to interrupt, but I think that I 100% agree with what you said. I think there's actually another dimension that complexity, right? So we talked about the complexity of the model itself being from static to like fully, self-learning,
Yeah.
But then if you think about companies that have done multiple models with impact on the same customer, then how do you synchronize each like the outcome of all these processes into like but so
Customer
and it go
360.
exactly that's exactly right. So I think in the context of the recommendation engine we're trying to do, right? Well, the recommendation engine needed to be aware that you were eligible for the product being recommended, right? In other words, like if you are a young, right, if you were a young customer with no kids, like, it wouldn't make sense to recommend the type of product that was much more, attuned to like, families with 3 kids, right? Or if it's recommending a loan, like, were you even eligible for a loan given your, because we as a credit institution, as a financial institution at that point in time, knew all these things about you, right? So why would we recommend you something that makes no
Don't
sense to
confuse
you,
the
right?
customer. Get an
Exactly.
integrated story so that you don't.
Exactly.
I
So
have a funny story. I love my bank. I have Chase. I'm with Chase for many years as a business banking as well as private banking. Um, I have a ink, Chase ink or something for many years. But every 3 months, Chase sends me this, like, get an ink card. And I'm like, how long will it take you to learn that I
right,
have already had an ink card for
that is exactly
7
right.
years or 10
That's
years?
exactly right. And I think there's the interesting thing, like many times, it's about some of these processes may be or may not be model based, but it's just about the data, right? That's why the data is so important. I make sure that, am I doing the right thing, right? I think the example of the recommendation engine, we had one of the top products being recommended was like wealth management. But then if you look at the population of clients of the bank I was working with at that point in time, a bulk of them were like young kids just starting their careers, and so wealth management makes no sense for them, right? I think the similar story to yours is many years ago, I had a Nissan Leaf, right, an electric Nissan Leaf, right, which I bought at the dealer, right, and every month I would get from the dealer like a postcard for a discount on oil change, right? Like, Leafs have no oil, right? More than Nissan Leaf. So, but like, to your point exactly, like after a few times I actually went to the dealer and said, hey guys, I'm here for my free oil change, right? And like, but you have a Leaf, like that's exactly my point. Like, why like, stop wasting the money on this thing because you're just not, clearly your data is not talking to each other. So I think that goes back to the point of the importance of data from again, understand the ecosystem, right? And that will make your model significantly better, because otherwise, again, you'll produce incorrect recommendations, you'll do, maybe incorrect actions, or in some cases, like, I mean, it's a fun, like you and I like sort of laugh about your case, the ink card, my case, the model change. But in some case, the consequence may be something that is like deeply offensive, right, or deeply unacceptable and you may actually be damaging the customer experience, right, from that perspective. So,
I mean, I think irrespective, I mean, I'm sure this is Chase, they're very sophisticated. I'm sure it's coming out of some model which says she's at ink card, she's going to have ink card. She's most likely to, take your offer of an ink card. But the point being that you're wasting, because I'm getting that like whole whatever letter and all of that. It's costing them, let's say, $1 even, or maybe more on me every 3 months. You're wasting dollars, even though I have high likelihood of being on ink because I am on ink.
Yes.
So,
well, I think the other thing is also from a customer perspective that sort of makes you wonder, like, but you guys have all this data about me. Well, how come you don't know me if I'm giving you all this data, right? So it's
My
like that sort of
complete banking is with you and you're still giving me this. Like,
exactly.
my 2 credit cards, my 4 bank accounts, and you're still, you still don't know me enough.
That's exactly right. That's
That's
exactly right.
quite silly. So I think in just what we were saying about this last part of conversation was that look at your customer 360, whether you're using model or not, but create a single interface for your customer, that the different models are not competing against each other for the same customer's attention, because
Right.
then you'll be, this model is saying, recommending one things to me, the other model is recommending the same thing. You guys need to have a cohesive story of one customer,
Exactly.
one recommendation or one story, so that there's not competing, even though departments inside might be different and the models might be
Yeah.
different or whatever else.
And I think in that regard, that sort of that point you just make is fantastic. Sort of bleeds a little bit into organizationally how you do this, right? I think, a lot of departments may end up having their own sort of data science capabilities. So if you have the marketing team doing their own sort of segmentation models for those things, that's great, right? And then if you have let's say the customer service department doing some other things, right?
Yeah.
In the case I talked about, we were lucky because data science was a central service, right? So we were I was both supporting marketing and supporting customer service. So I could actually we could link the segmentation. They had a rudimentary segmentation model, which we actually used the data to feed the recommendation engine to make sure that the recommendations match the segments, right?
Yeah.
And similarly, we're working with credit risk, doing the credit risk model, so we could actually make the inputs but that works when you have sort of the collaboration between data science and data services, right? When you have silos, then that's when you have situations in which, like, marketing running a campaign to say, yep, Bianca's eligible for this product, and then the cards department say, but she has it already, right? Like, why am I recommending that to her? I think that's something that, again, as people who are getting into this space and are wanting to do things, just that business awareness of what's going on, and that, again, I don't saying centralized or decentralized. I'm just saying collaborate, right? Just look at it from the customer perspective and say, what are the touch points that have been influenced by data, and how can we make sure that is synchronization across all of them?
Yeah, that makes a lot of sense. So I would like to shift gears. I think we've been talking about your stories are from large companies. I've been referring to Chase and all large companies. Many small companies are now competing on data. They are starting with a lot of data as an advantage, and they already have their whatever on cloud tech stack, whether it is GCP or Azure or AWS, and they are playing with the data, and they're hiring their first data scientist. That the dashboards exist and so on, but now, hey, well, we should build some models and leverage that data. Really, they don't have silos, they don't have large organizations, 200 people organization. They are starting their first data scientists. So what would you, from the model management governance perspective, what is your sort of guiding thing you would like to add for these folks who are sort of early in their game but very tech savvy, and small?
I think my it's a great question, because I think, by the way, like, that's the majority of the companies, right? Like, the large companies are a handful, right? But the majority of the companies are going to be in some segment of some spectrum of what you described, right?
All app companies, think about all apps. They have tons
Exactly.
of data, what they click, what the
Exactly.
customer install,
Exactly.
everything. Yeah.
Well, I think there's a few things. When I talk to some data scientists that reach out for advice on exactly how to get started, my point to all of them is always, try to stay connected to the business problem being solved as much as you can, right? I think it's probably less likely to happen in a small company, because precisely there's smaller teams, right? So probably they're going to be the only one, or just a handful of data scientists. They're probably going to be playing multiple roles. They're going to be doing some business analyst work, some dashboard development work, some BI work, some data work. So there's playing multiple hats, right?
Yeah.
But I think what I've seen data efforts fail usually, or sort of or fail to gain the right traction, is when there's isolation, right? When someone just locks themselves in a room and starts saying, I'm going to solve this problem with the most beautiful model, with the best algorithm, with the best tools, right? The most up-to-date, libraries. They're going to take me 6 months to do that, but I'm going to perfect. Like, so that isolation, right, is something that may lend itself to over optimizing the problem, right? And I think when that happens, because people are trying to solve just one link on the chain, I'm gonna the model link on the chain, right? I'm gonna, and then, to your point before, if you end up with a fantastic model solving that what do you do with that? Like,
Yeah.
how do you link it to the outcomes, right?
Yeah.
Have you talked to
It's
the right
not
people?
solving your business problem.
Exactly,
It's
exactly.
also the
And
decision was made 3 months ago. Your model is 3 months late. Also, there are
exactly,
nuances and constraints
exactly.
you didn't understand. So yeah, that's a
And
really good point.
many times it can be solved, to your point, with a very basic, very simple solution, and use
Yeah.
that to gain the
Don't even
trust of
need
the
a
business
model.
stakeholders. Exactly. And then many times, just when you gain the trust of the trust of the business stakeholder, then iterate, make it better every time, make it better
Mhm.
every time. But think systemically, right? Think
Yeah.
end to end from a business perspective.
That's a very good point, Juan. And that's where you and I shared the Bader framework with you,
Yeah.
which marries the data science with decision science. And, it's a data science, decision science framework, but it doesn't, the first step in that Bader framework, it's an acronym for these 5 steps. The first step, if you notice, BADIR, data collection, is step number 3. Your data,
Right.
it never starts from data. Your model building or your approach to solutioning starts from business question, and then laying out an analysis plan, a systematic way of approaching, but also making sure that the data science is feeding into the decision science, where who's going to be working, who's actually going to be acting on your recommendations, who
Right.
needs your solutions, what are their constraints, when do they need to make decision, what actions and decisions they are ready to make. Are they ready to make product changes? If they're not, they're only ready to make marketing changes, then you need to think differently of that model or that analysis.
Exactly.
And to your point, sometimes the model is not needed. Sometimes a simple correlation will give you enough
Right.
traction. Version 1. Version 3, you might need to build a decision tree. Version 5, maybe you can think about machine learning, GBC, and so on.
That's
And
exactly right.
version 7, you need to think about productionalizing, whatever else. So it's a walk before you, crawl before you walk kind of situation.
Exactly.
But think systemically, I think and
Yes.
systematically as well. I think many of these tech stacks now are, at least the cloud platforms have this. So if you talk about GCP, GCP, AWS, and Azure, they have already systems built in where you can do end to end of that. Even products like
Right.
Alteryx, you can connect it to your various data sources. You can actually build model, right? Because you can do a Python, and I don't know how familiar you are with Juan, but I just played with it. You can build model using drag and drop in Alteryx, but also there is like Python and R, I think they're called nodes. You can fire that up, route codes, and then there's a way to also productionalize it. So there are many tools out there which are in cloud, which are very very helpful these days. So I think the constraint is not there. The constraint is, or the more larger thing is to paint a larger picture. Don't oversolve it, and make sure that you're connected with the business.
Yes.
Right? Always.
Absolutely. I think to another point that you touched before, like my advice also, the younger the company is, the store as much data as you can, right?
Yeah.
Automate, instrument everything, right? And collecting data today is so cheap, right? Like storing data today, and to your point, like cloud storage is like, it's gone down significantly in terms of the cost. So the cost of storing that data is significantly less than it used to be. And many times you don't know what you're going to use it. And the more granular the data, the more history you have, the better you can maybe use for some products, particularly if you're just starting as a company, right? I think that
Collect as much data as you can, because
exactly,
you find it useful.
exactly.
And then because I'm living this pain right now with one of our clients, is that please aggregate and normalize it, because if everybody keeps hitting the most granular level of data, and then you'll
Right.
be filtering and saying percentage US. That means you're going to be fighting four SQL levels up, saying, well, how did you filter it by the right country?
Yes.
You don't want to do that either. So collect as much data as possible, but create systems in which your data is normalized and aggregated at a most usable form. So your product analyst and SQL analyst are not fighting in saying, spending time reconciling the data, because
Right.
did you really use these 400 filters you needed to use to get
Right.
your data? So this has been very useful conversation, Juan. I learned a lot. Hopefully the folks who are watching and listening to the Analytics Cafe podcast will continue to do so. How do, just like last parting words, what are your top 1, 2, 3 takeaways from this conversation?
I think the last piece that we just talked about is sort of a nice summary, right? It is the what is the business problem you're solving,
Yeah.
right? Regardless of a data science, what is the business problem you're solving? The second piece to that is do do you know the business outcomes of solving that problem? Like, how much value is it going to create, right? Is it going to increase revenue, reduce costs? What is it going to save time? Like, because I think I think what that forces you to think as a data professional is to make build the right relationship and build the right linkages to the business people to say, if we solve this problem, right, then we're going to create X amount of value. That'll be a key input in prioritization, right? Because as a data scientist in a large organization, there's going to be more demand than supply, right? There's going to be more demand for projects, and you'll have to figure out a way of how do I prioritize, my work. And I think that linkage has to be to business outcome, right? I think that the third piece we talked about, or the other piece we talked about, is thinking systemically, right? Like, end to end, right? And that includes in the business process, but also includes sort of technology stack. As we were saying before, if the model is going to have the highest impact when it's deployed in production, interconnected to the systems that support the business process, then you have to think about that, right? And that has a different requirements that to say, this is a model that we can run on a batch mode, every once a month, and that's enough. Then you can use it on the desktop. Like, just that the requirements are going to be much less, right? And usually, and the other piece that I would say that like in closing is again a cliche again, but it's data, right? Like, how overlooked data is, right? And how important it is to understand data, right? And just in many cases, perfect is the enemy of good, right? Just do what you have with what you do, what you can with what you have, right? I think the story I have in that regard is that in my prior role a few years ago, we actually ran a data hackathon with one of our biggest clients in Europe. And we pull a production data set, like, I think it was 500 million rows of data, put in AWS, right? And unleash a bunch of data scientists that were part of the hackathon. And so this was production data that had been anonymized. So we had actually hashed some columns, but for the most part was production data, right? And the first night, Friday night, we hold a Q&A session with the participants, and they, the biggest question we had is like, oh my God, the data has so many data quality problems, right? Like, there's all this hole. I said, guys, guess what? Like, this is production data. This is real life. Like, people are used to perfect data sets for data competitions, right? But then you realize that, like, so my question to them was, what are you going to do about it? Like, are you going to delete, like, are you going to eliminate some rows? And what's your logic to do that? Are you going to actually fill some holes? And what is your logic? But you have to move on, because this is a production data set. So again, pay attention to data, collect as much as you can, but also realize that there's no perfection. Exactly, there's never going to be perfect, right? And you need to move on, and you need to do with what you have.
Yeah, that's a very good point. So just summarizing, Juan, what I heard from you is focus on the business question. Make sure that you are outcome focused. Think about it first before, as you're starting. And then the third point that I understood was think systemically. How are you going to get this output, rather than before you start, like basically plan before you do. So and that's our analysis plan stage that we have with the Bader framework. So this is very good advice. So last question for you, Juan. For those who are looking to get in touch with you, what's the best way to find you, and how do you like for people to reach out or connect?
Sure. So I'm going to be tagged in LinkedIn when this is live. So that's the best way to find me. Like, I'm more than happy to connect anyone, chat with anyone. So that's the best way to connect with me.
So find Juan Gorricho on LinkedIn and follow, or reach out as you like. And this has been a pleasure, Juan. We both are very passionate, as you can see, as we start speaking and rambling faster and faster. But it's been great. I hope to continue to have this conversation in ongoing fashion, and hope people found value, and see you all next time.
Sounds good. Thank you.